Alright friends, welcome back. In this video I'd like to go ahead and take a quick look at section P.6 in your textbook. And it does say day 1 here, but we're only going to take one day for this section because it's kind of short. But in this video what I want to do is take us back to the coordinate plane where we are plotting points and we're doing specific calculations on points like calculating the point in between 2 points, the midpoint, and also calculating how far apart they are. So that's distance formula. So let's get into that. Okay, so given 2 points, and you might call their coordinates x1, y1, x2, y2. The 1s and 2s there, that's just signifying that that is going to be your first set of coordinates, your second set of coordinates. But let's say I want to calculate the point that is directly in between these 2 points, so the midpoint between. Well, in that case, we would use this formula right here, okay? And if you take a look at this formula real quick, what you'll notice is that what you are calculating are the coordinates of a new point, okay? So if you were to take a look at your x-coordinate and your first x-coordinate and your second x-coordinate, all you're doing here in the midpoint is taking a quick average of those 2 coordinates, and then that's going to be the x-coordinate of your midpoint, okay? And it works the same way for the y-coordinate. To get the y-coordinate of your midpoint, you're just going to take a quick average of your 2 y values here, okay? So again, remember how you take an average of 2 numbers. You just add them up and divide by how many there are, and that's exactly what you see us doing here. And just to be clear, whenever you're calculating midpoint, that is the quantity that you are calculating, are the coordinates of a point, okay? And just like all coordinate points, what you're really calculating here is a location, okay? So that's what a coordinates are, is starting at the origin, you use the coordinates to get to where you're going. That is going to be a location. So that's what you're calculating when you do midpoint. When you're doing a distance formula, you're calculating something a little bit different. You're calculating how far the 2 points are going to be from each other in the coordinate plane, okay? And this is a formula that comes to us from the Pythagorean theorem. There is a way that you can interpret the distance formula so that you're drawing a right triangle in the coordinate plane and then calculating that. But again, I just want to kind of drive home the point that what you're doing here is you are calculating a distance between 2 points. Or in other words, it's going to be a certain number of grid squares in the coordinate plane. So we'll write that down there real quick. That's a Q. Okay, so I don't want us to forget that we are using the same coordinates as before. Okay, so we are going to use the y coordinates here, and we are going to use the x coordinates in this calculation, so we'll keep my colors the same. And I want us to kind of hone in on the fact that when you do distance formula, you are going to be performing a total of 6 different operations whenever you do distance formula, okay? What you're going to be doing is you're going to be finding the difference of your x coordinates and squaring that afterwards. Okay, so that's 2 operations. You're going to be doing the same thing for the y coordinates, finding the difference of the y coordinates and then squaring that afterwards. So we're up to 4 operations. Once you figure those out individually, you're going to be adding the results of those 2 together, and then whatever you get as the sum there, you're going to take the square root of the sum, and that is going to be your distance formula calculation, okay? So there's a lot going on in distance formula, which is why if you can let most of that work be done mentally, it's going to be quicker and it's going to minimize mistakes, okay? So let's see that here in a couple of processes. So just for the sake of time in the video, I've already kind of set up my midpoint and my distance formula calculations here. What I would like to focus more on is just on plugging the numbers in and then how we would go ahead and work these formulas out, right? So in this first one, number 1, I've just got the points with coordinates 6, 3, and -1, -5. And so if I'm trying to do midpoint formula to start off here, I need to perform an average of my x coordinates and then an average of my y coordinates. So it looks like playing the roles of my x coordinates here are 6 and -1. So when I plug those into my formula, I'm just simply, again, taking an average of those 2 numbers. So 6 plus -1, and then we divide by 2. Well, 6 plus -1, that turns into 6 minus 1, and if I divided that by 2, that would give me a quick 5 over 2. We'll just write it as a fraction that way. And then if I move on to my y values, then I'm going to be doing the same thing just now for the y values. So here I have 3 and -5. So if I plug those in, I'm going to have 3 plus -5, which we'll adjust my pen tip there. 3 plus -5. That's going to give us -2 in the top, divided by 2, that'll give us a -1, okay? And so, in order to calculate the midpoint, we will go ahead and stick with this formula here, okay? Now, truth be told, it does not matter what I call x1 and y1 and x2 and y2. We just need to keep it consistent. So, the way that I did this was I went through and called these numbers, these names here. My first x, my first y, my second x, my second y. But truthfully, because we're dealing with additions and that kind of thing, it truthfully does not matter which you call which, okay? When we move on to distance, it's going to be the same process. We're going to be plugging in our x coordinates, finding the difference of our x coordinates real quick. So we'll plug those in real fast. And then the same thing for the y coordinates here. So we'll do 3 minus -5. Now, if you can go ahead and work these two groups out mentally, then that is going to be something that I feel like is going to help you a lot here. It's going to be a lot faster, and it's going to minimize mistakes, okay? So if we just go ahead and focus here on this first group, right? The difference of my x's squared. Well, that's a 6 minus -1. That'll turn into 6 plus 1 because of the double negative, and so that'll be 7. And then after that, I want to take 7 and I want to square it, which does mean I'm going to ultimately end up here with a 49. So I'm just going to go ahead and leave a 49 there and hold on to that value. And now let's move on to your second group. Okay, so again, some mental math I think would be a lot quicker here. So that is a 3 minus -5. The minus negative changes to a plus. So that'll be 3 plus 5, which makes 8. And then if I want to square that, 8 squared, of course, is going to be 64. Okay? And so what do I need to do now? Well, I have my numbers that result from doing the differences squared in both groups, the x's and the y's. So now all I have to do is just simply add these two numbers together and then perform the square root. Okay, so that's exactly what we're going to go ahead and do now. So when you do 49 plus 64 in the calculator, what you're going to end up here with is 113, and we, of course, need to take the square root of that. So if the directions had asked us for an exact answer, the only thing we would need to do is check to see if this is a square root that we could write in simplest radical form. And I will spoil the punchline here. 113 is a prime number, so there's no other numbers that go into it besides 1 and 113. So there's no way to really break up a 113. So that would be our exact answer. And then, you know, since this is a distance, we might be interested in the approximate value of this. And if you were to punch that into the calculator, you would get 10.63 units, okay? And so again, I might go ahead and label my distance there and just simply say units because, again, just driving home the point that this is a distance. This is not a location. This is a distance between 2 points. So that's just a quick demonstration of how we would go through and plug our values in to calculate midpoint and distance separately. Let's see that again. All right, so here in number 2, I'm giving you these coordinate points. So it looks like one of your coordinates is going to be a fraction, but that doesn't mean that anything changes here. We still want to go ahead and perform the same operations in our formulas as always. So I'll go ahead and start here by doing the average of my x coordinates. So that will be a 1 over 2 plus a -1. And then we will divide all of that by 2, okay? And so if I take my calculator here and do that really quickly, we'll go ahead and figure out what that answer is going to be. If you do that correctly, you should be ending up with an x value here of -1/4, okay? So I'm just doing it in the calculator quickly for the sake of time. For these y coordinates, okay, so -3 plus 2, it would be the same process just now for the x or for the y coordinates, right? So we'd have -3 plus 2. This is one you could do very easily mentally. That's just going to be -3 plus 2, that's -1, divided by 2, that's simply going to give you a -1/2, okay? And so again, this is a location of a point. We can still plot points even though the coordinates are fractions. It's just going to mean we'll have to plot those using parts of grid squares instead of just where the grid squares cross very nicely. And then finally for the distance here, again, we are going to do the difference of your x coordinates. So that's going to be 1/2 minus -1. And then for your y coordinates, same thing. It's going to be -3 minus 2. Okay, so again, if you could do these mentally, then that's going to mean that that's going to be pretty strong for you to do because it's going to be a lot quicker and we're going to minimize mistakes. A little bit tougher to do here because you are dealing with that fraction. So this is one where if you want to use the calculator, you have the green light to do that. So we'll do that here really quickly. I'll use the calculator. 1/2 plus 1, that gives me 3 over 2. If I square that, I'm going to get the fraction 9 over 4. Okay. So I just went ahead and I did that first group in the calculator, doing all the operations, I get 9 over 4. If I do that second group, that's one I could do a little bit more mentally because I'm looking at those integers there. That's -3 minus 2, that will give me -5. If I square that, that's going to give me positive 25. Okay, so I know what will result from doing the difference of my x's squared and the difference of my y's squared. I end up with 9 over 4 and 25. So if I take those now in the calculator and I add those together, 9 over 4 plus 25, then what I end up with here is a fraction that looks like 109 over 4. Okay, and if I was interested in the exact value of my my distance, then I would simply have to go ahead and carry through the square root. Remember, we don't like to see square roots in the denominator, and so in the denominator there, I see a perfect square number like 4. That's something I could take the square root of really nicely. That'll just simply be 2. So I end up with a 2 on the bottom, and then on top, 109 does not have any perfect squares that go into it. So if we were looking for our exact answer, this would be it right here. And then, of course, if we were looking for an approximate answer, we would just have to go ahead and take that value and plug it into the calculator. And if you do that, you're going to end up with 5.22 units approximately. Okay? So these turn out to be longer decimals here, so I'm just writing these and rounding to the nearest hundredth, but that would be a quick demonstration of how that works. And then we'll do one more example just for sake of completeness here. So again, one last time, we're going to do the exact same thing. We're going to go ahead and do the sum of my x-coordinates and divide by 2. So that'll be 6 plus -4 and divide by 2. That one's a little bit easier to do mentally because 6 plus -4, that'll turn into 6 minus 4. That'll just simply make 2. And if I divide that by 2, I end up with an x-coordinate of +1. For my y-coordinates, same thing. I have a 7 and an 8. And so if I go ahead and do that, 7 plus 8, that'll make 15. If I divide that by 2, 15 is not really a number that can nicely be divided by 2, so I would just leave it as 15 over 2 there, and that would be your midpoint. And I want you to notice how quick that goes, right? You do enough of these, you get enough practice, you build enough confidence, these can start to be some calculations that you do really, really quickly. Again, you're just taking two averages and leaving them as fractions if possible, okay? Now moving on to distance. Again, same process as before. We're going to go ahead and do the difference of my x-coordinates here. So I have blue x-coordinates of 6 and -4. And then I have my green y-coordinates of 7 and 8. Okay, so when I do this, again, if you can do this mentally, it's going to be a lot quicker, and it's going to minimize mistakes for you. So let's go ahead and take a look at that. So if I take a look at my difference of my x's squared, that's going to be a 6 minus -4. Minus negative, that changes the operation to plus, so that's really 6 plus 4, which is 10. And then if I square 10, I get 100. So when I do the difference of my x-coordinates squared for my x's, I get 100. When I do my y's, that's simply 7 minus 8. That'll make -1. If I do -1 squared, then I get 1. Okay? So again, if you do those mentally, that's going to be really, really easy for you because now when we do distance, all we're going to have to do is add them together and then apply the square root. So if I add 100 plus 1, I get 101. And if I do the square root of 101, I will spoil the punchline there. The square root of 101 is not a square root that is going to simplify nicely for you. So there is our exact distance right there, no rounding involved. But if we wanted to get an approximate distance, we would just have to punch that in the calculator and get a nice approximation. And so if we round to the nearest hundredth, just like the other ones, that would be 10.05 units. Okay, so again, last little summary here, right? When you calculate a midpoint, you're calculating the coordinates of a location, okay, of a single point. When you're calculating the distance, you're actually calculating a number of units between those points. How far apart are they, okay? So just a little bit of geometry review when you talked about midpoint and distance. So let's go ahead and move on here. So the next little blurb of questions, and this will be the last thing that we cover in the video, is answering questions that ask us which quadrant are we in, okay? So you can see here in all these examples, I'm giving you some sort of object. I'm either giving you the equation of a line, or I'm giving you a point, or perhaps I'm giving you the description of a point. And what you have to do is use that information and determine which one of your quadrants you lie in. So really quickly, let's just review how the quadrants are ordered, right? So if I go ahead and draw my x and y axes here, remember that we would go ahead and start in the top right. That would be quadrant 1. So I'll say Q1 there. And then we start to number them going in a counterclockwise direction. So in the top left, that would be my next quadrant I want to number. That would be number 2. In the bottom left, that would be quadrant 3. And in the bottom right, that would be quadrant 4. Okay, so the order of your quadrants would be something I would expect you to know, but just a quick review there. You notice for this first one that I went ahead and I went to my calculator and I created a graph for this in the calculator. If you guys are needing additional help with graphing in the calculator, then please come see me. I'm not going to show you all the steps for that in the video just to kind of save time, but you'll notice here that when I graph that line, part of the line shows up in a couple of quadrants, right? So we have part of the line that shows up here in quadrant 1, we have part of the line that shows up here in quadrant 2, and of course part of the line that shows up here in quadrant 3. We are missing quadrant 4 a second ago. We are missing quadrant 3 here. And so we basically touch on every single quadrant except for 3. So for my final answer here, I would simply go ahead and list all of those quadrants that this line is going to lie in, and that will just be my final answer for that problem, okay? So if you can get used to using the calculator there, these problems tend to go really quickly, Okay. And number 5, that might be a little bit more reminiscent of a previous algebra class. You might remember the mnemonic device HOI. That stands for a horizontal line has a 0 slope and says y equals, aka it goes through the y-axis. But this would be a horizontal line, okay? A horizontal line. And if we were to go ahead and create a quick sketch just by hand of this, then I might go ahead and draw some x and y axes here. And because it says y is equal to positive 7, then that means on the y-axis I'm going to go up to positive 7, and I'm going to go ahead and plot a horizontal line there, okay? And so again, if the question is what quadrants are we in, we'll just take a look at over there off to the right. We are in quadrants 1 and 2. So that's all I'm asking you here. What quadrants are you in? If you, let's go ahead and skip around, because if you look at number 9, that is an example of another type of thing from a previous algebra course. This is something that you might remember, the mnemonic device VUX, V-U-X. Okay, and that stands for vertical lines have an undefined slope and say x equals, or in other words, they pass through the x-axis. Okay, so if we draw a quick sketch of that, then on the x-axis, we would just go to where negative 5 lives, and then we would plot a vertical line right where negative 5 lives. Okay, and again, if the question is what quadrants are we in for that line, that answer would be we are in quadrant 2, and we are also in quadrant 3 for that object. Okay, so if you have a HOI, a horizontal line, or a VUX, a vertical line, then you can just create some quick sketches of that and then determine what quadrants you're in. If you look at ones like 6, 7, and 8 here, what I'm doing here is I'm giving you the description for a coordinate, okay? So a coordinate point, I should say, right? So coordinate points, we remember, are always going to be something that looks like an ordered pair. We have an x-coordinate and a y-coordinate. And so what I'm saying here is that in this coordinate point, you have an x-coordinate that is greater than 0, and you have a y-coordinate that is less than 0. And just keep in mind that what we mean by this is that, you know, if you're greater than 0, then that, of course, means that you are positive. So we're saying that your x-coordinate is positive, and if you are less than 0, then that means that you are a negative value, okay? So we just might need to brainstorm on where this point would be plotted if its x-coordinate was positive and if its y-coordinate was negative. So maybe a quick sketch might help with that, right? If you're looking here at this sketch, right, where are we positive with your x's? Well, we know that x is positive right here. This is our positive x-axis. This is where your x's live that are all greater than 0. If you have a negative y, then where do they live? Well, they live on the negative y-axis, which would be right here. Okay, so all of the y values that live on that part of the y-axis, those are going to all be numbers that are less than 0 or negative. Okay, and so if you kind of take a look at the quadrant that we've kind of separated from the others here with these two regions, we definitely see here that we have this quadrant to work with, and that is going to be quadrant 4. Okay, so it turns out that our answer here for number 6 is just simply going to be quadrant 4. So if you have a positive x value and a negative y value, you're going to be stuck in quadrant 4. So that's the thing that we need to perform here. If you look at number 7, same thing. I have a positive x and I have a positive y. So if we were to take a look at a quick sketch of a graph for that, then my positive x-axis, of course, is right here. This is where x is going to be greater than 0. My positive y-axis, of course, is right here. This is where y is greater than 0. And if you take a look at the quadrant that chunks off, then that, of course, is going to be quadrant 1 here in this example. So our answer for this, of course, is going to be quadrant 1. So again, I'm just giving you a description for the x and y coordinates and then saying, you know, where would your point lie if it met those descriptions there. And then a couple of last ones here. If you look at number 8, what I'm saying here is if you take your x coordinate and you multiply it times your y coordinate, you get something that is greater than 0. Okay, and I want us to brainstorm about that, right? I want us to brainstorm on all the different situations that are possible where we can multiply two numbers and it would be something that is greater than 0. Okay, so you're thinking about the signs of numbers here real quick, and what you may come to is the fact that if you have, let's say, a positive number times a positive number, then that is going to give you a product that is greater than 0, and it actually works the same way if both the numbers are negative here. So if you take a negative number times a negative number, you're also going to get something positive, right? And so these are the only situations. If you had the case where one of them was positive while the other is negative, then we would no longer be greater than 0 with our product. We would be negative in that case. Okay, so what we need to do when we create our sketch is we just need to go ahead and figure out, you know, I want my x-coordinate and my y-coordinate to have the same sign. Where does that occur? Well, that is going to only occur in quadrant 1, where your x is positive and your y is also positive. and it could also occur in quadrant 3. I'll use a Roman numeral there. This is where x is going to be negative and also y is negative. So basically the question here is, where are your x and y coordinates the same sign? And the answer would be in quadrant 1 or in quadrant 3. Last example of the video here, we're asking about the simple point 6, 0. Which you may say to yourself, well, there's no real challenge here, but if you create a quick sketch of that and you remember where 6, 0 lies, that would be on the x-axis right here. Okay? And that's kind of odd because that point is not really sitting in a quadrant, it's really on an axis. It's on the boundary between quadrants. Okay? So what I want you to do here is I want you to kind of think about this being like your backyard, right? So if this is your backyard in quadrant 1, and this is my backyard here in quadrant 4, then where would my point be? Okay? Well, you might consider the point to be sitting on the fence that separates our two backyards. So if you're sitting on top of the fence, whose backyard are you in? Well, you're not really in anybody's backyard because you're sitting on top of the fence that's in the middle. And so this would be a case where I would not say that we are sitting in any quadrant. Instead, we're sitting on the boundary of a quadrant. And so the correct conclusion here would be to say that I'm not really sitting in any quadrants here, and I'm sitting in none of them because I'm sitting on an axis instead. Okay, so that's just a really quick overview of all the different possibilities for questions that I could ask where I'm asking what quadrant are you sitting in. It's just a matter of taking a look at what you have and figuring out what it would look like in the XY plane and then determining what quadrant you would be in. So I hope this video has been of some help to you. Please let me know if you guys have any questions whatsoever. That's all I have for this video. Thank you very much for your attention, and I will speak to you, of course, in the next one.